Hello everyone. So, this is lecture 2 for the module 5 for the course Computer Organization and Architecture. In this lecture, I am going to talk about the external memory. In the previous 2-3 lectures, I talked about the internal memory and cache memory and so on. So, this lecture I am going to talk about external memory. In this external memory, particularly we look for the magnetic disk characteristics and its performance related parameters. So, as we discussed in the previous few lectures, computer memory system is basically a hierarchy starting from the memory which is available right in the processor chip itself, and then outside the physical memory or main memory, and then the for mass storage or for the larger storage data, for to store the large amount of data, we require the external memory. So, not a single technology, memory technology, meet the requirements in terms of the cost and the performance. So, that is why we have this hierarchy. So, the semiconductor memory that we discussed in the previous 2 lectures, it cannot be used to store the large amount of data. It can be used, semiconductor memory means the static RAM and the dynamic RAM, that cannot be used for storing the large files, because the cost will increase. Per bit cost is very high for this memory compared to the amount of data which we are going to store, or we require to store the data in terms of that we use to access, or the processor not going to access directly, or not going to access less frequently. So, for the large storage requirements is fulfilled by the lower cost memory, that is the magnetic disk or optical disk or magnetic tapes. In optical disk we have CD, DVD and all, and this type of memory is called as also called as a secondary storage. So, it is a less it is a data which is accessed less frequently by the processor. Now, if you look at the how this disk or the secondary storage or external storage is connected to the processor. So, in this diagram you can see processor and the main memory. I have not shown here the cache memory, the level 1, level 2 and all these cache memory. The simple traditional the system I have shown here, processor and the main memory connected by the rest of the system through the system bus, and this is the secondary or external storage, disk drive. It is connected through the system bus via a disk controller. So, this disk controller works as an interface between, it is an interface between the system bus and the disk drive. So, this controller takes care of the about the speed mismatch, the data transfer rates mismatch between the system bus and the drive which is connected to it. A single disk controller can control more than one disk as well. So, you can have, let us say, disk 1. So, this is disk 2, also can be possible that one controller is controlling the 2 disk or more than 2 disk as well. So, you can see here the processor is not going to directly access the disk drive, and the data here, what data we are going to put, the data which is not frequently required. Frequently required data, the program that we are going to run, that will be available, that is available in the main memory, and for further reducing the access time we have the mechanism, or we have the memory which is called as a cache memory. So, we have the different levels of the cache, on chip cache and off chip cache and so on. And whenever the data, so initially when you start program, you load your program from disk to the main memory, and then for a long time that program is going to be run. And finally, for the permanent storage, you can keep your data in the disk storage in terms of in the disk which is attachable disk, or that you can detach as well later, or you can attach the new disk, or magnetic tapes and so on. That is the offline storage, also it is called as offline storage. So, today we are going to talk about this offline storage. So, the magnetic disk is a very common storage medium which is used for the secondary storage. It uses a disk substrate, the plater, which is also called as a plater, which is form of the known magnetized material. Say for example, aluminum is mostly used earlier, and this aluminum plate is coated with the magnetizable material, say for example iron oxide, and on this magnetizable material the data is recorded. Later on, this aluminum substrate is replaced with the glass substrate. There are few advantages of the glass substrate. One is it improves the surface uniformity. You know, the disk rotates at a very high speed, let us say 15,000 revolution per minute, it's a very common 7,200 revolution per minute. So these are the probable speed at which the disk is going to rotate when at the time of read or write operation is going to be performed on that. So at this rate, if your surface is not uniform, then the disk or the disk head can damage. So improved surface always is better. Reduction in surface defects, this glass substrate provide the better read write mechanism in terms of giving the low error rate, and it also gives the lower fly heights. Earlier disk let us say floppy disk. So there are the two types of magnetized material. One in earlier systems, there the floppy disk was there that you can detach from your system as well. In a floppy disk, the plater is there and the magnetized material coating is there on that. On that the information is recorded. Now the head, which one head is there that is used to read the information or write the information. So head has to move at the appropriate location. We will see the disk organization later, but right now let us say this head has to locate on the disk at some position to read or write the data on that location. So whether this head is touch the surface on which the information has to record or read, or so earlier in the floppy disk the head is going to touch the surface, recording surface. So whenever the disk has to rotate for reading or writing purpose, this head damages that recording area, surface area, and after some time this disk is out of order, you can say. Now for the disk, floppy disk, it was okay still, because the speed at which the floppy disk is going to rotate, that is very low speed compared to the speed at which this hard disk rotates, or the platers which used in hard disk that rotates. It is as I said, that is a 15,000 revolution per second, that is a normal speed. So at that speed, if the surface, if your head is touched to the surface, then it can damage the head. If even a fine particle, let us say a smoke particle also come, or a fingerprint kind of particle comes in between the head and the recording surface, it can damage the surface as well as the head as well, or your disk can be crashed. So that is why nowadays in the hard disk the head is not exactly touching the surface, it is just above the surface, and the distance between head and that surface is in nanometer, 2 or 3 nanometer. So that is the one advantage. So now head it is called as a flying or floating head. Its head is floating over the surface, it is not exactly touch the surface, and then the glass substrate provide the better stiffness and is a better shock resistance as well. So this is how your magnetic disk looks like. So in this disk you can see this is the plater, aluminum plate or glass plater on which the magnetized material coating is there, or you can say is a recording surface, and it rotates on this spindle, and this is a head, read write head, it is called as a read write head. You can see this head has to, so for any read write request generated by processor, this read write head has to move to the appropriate location on the disk, and then the information, either the recorded information can be sensed or the information which is provided, that can be written on that. So, this is a mechanical stuff, means this head can move and record the information, or recorded information it can read. And this is the other external associative circuitry which is required to rotate the disk as well as record the information which is required. Now, let us look at the organization of the data on the disk, how the data is organized, because if you look at the platter, you cannot recognize that where the data is there, how the information is there on the disk. You cannot see from your naked eyes, but how internally this information is stored such that it can be retrieved later whenever it is required. So, in this picture you can see the complete recorded surface, or this circular disk, is divided into some areas. So, these areas are called as a recording areas, that these are called as a tracks. So, there are concentric circles, you can see concentric rings, these rings are called as a tracks. This one, so this is a track 1, this is another track. So, like that the whole disk recording surface is divided into concentric rings, which is called as a tracks, and there is a gap between two tracks, and there are thousands of tracks are there on a single disk. Gap is required to differentiate between track 1 and track 2, and it also depends upon the head's sensitivity. There are same number of bits per tracks are there. Each track have the same number of bits which can be write on that, and this disk rotates with the constant angular velocity. Further, these tracks are divided into sectors. So, you can see this is a one sector. So, from here to here this is a one sector. I can say this is a one sector. So, the minimum, the one sector contains some amount of information, fixed amount of information. Usually it is called as a one block, and that block size is 512 bytes in general. So, at a time one block can be read and one block can be write. So, 512 bytes block you can read and 512 bytes block can be written on that. There is a inter-sector gap is also required between, as it is required for the inter-track gaps. So, this is gap between these two, so to identify or to differentiate from sector 1 to sector 2 and so on. Because the disk rotate at the constant angular velocity, in a given amount of time it traverses a constant angle. So, due to this it gives me a pie shaped tracks, sectors, pie shaped sectors. Here these individual tracks and sectors are addressable, means for reading any information which is stored on the disk, the head has to move first to the track, desired track, and then the disk has to rotate such that the desired sector comes under the head. So, this accessible method is what? It's a combination of direct plus sequential. So, directly head is reaching to the track out of these thousands of tracks which are there, and then the disk rotates such that the required sector on that track comes under the head, and then the track can be read, that sector can be read in sequence. Out of 512 bytes, the one by one the byte will be read from that sector. So, addressability is what? Here the tracks, individual tracks and sectors can be addressed. It is not traditional sequential like in magnetic tapes. So, it is a difference between the magnetic tape access method and the access method which is used in random access memory. So, it is a in between there. It's a combination of sequential plus direct. So, like this we understood that how exactly information is stored. So, the information is only stored on the, not on all the surface, stored on the tracks only, and the further the tracks are divided into sectors. So, just to for the addressing mechanism, so all the information is only stored at the tracks only. Now, we can see in this picture that we are getting, due to this constant angular velocity, we are getting the pie shaped sectors. So, in pie shaped sectors means the amount of information, as I said that okay, in each sector the amount of information is stored is same, 512 byte is a one sector. So, one sector is there in this innermost track. The length of the innermost track is less than the length of the outermost track, but the amount of information which is going to be stored is same. That is called as a single John recording disk. One John of recording is there because disk is rotating at the constant angular velocity. This means that the linear distance of innermost track and the outermost track is different, and number of bits are same, means the density of bits at the innermost track is more compared to the density at the outermost. That means we are losing the space at outermost or outer tracks, because the second track, that is again little bit larger, third is little bit larger, and so on. So, outermost we will get the maximum difference between the innermost and in terms of the length. So, the density is from inner, when you are moving from inner to the outer, then density is reducing. Density reducing means we are wasting the space, recording space. So, can we utilize this thing? The answer is yes, we can utilize by using the multi-John recording disk. So, we can say the disk storage capacity in constant angular velocity system is limited by the maximum recording density that can be achieved on the innermost track here. So, the bit spacing is here at outermost track, bit spacing is more compared to the innermost track. So, here basically we are wasting the space, recording space. So, we can utilize this recording space or the wastage we can avoid by making a disk of multi-John. Here the single John of means disk is rotating at the constant angular velocity. Now, if this, so as per the tracks I have the different zones. In general, the 16 zones are common for the multi-zone disk. 16 different zones are there. So, in this particular diagram, here in this diagram you can see each track is have its own zone, means the length, linear length of the sector is same, because the circumference is increasing from, you are moving from the inner to the outer side, then the more number of sectors can be accommodated on the outer tracks. So, like that you are able to utilize the space, you are able to store the more data or more bits of information as per the track size, but the timing of the information recording and reading will be different. So, for each zone you have the different rotation speed. The disk has to rotate with a different speed, depends upon the which zone the request is, for which zone the request is there. So, zone wise the velocity will be different. So, the control circuitry will be complex for these kind of disk, but definitely the space utilization or recorded surface utilization is better compared to the single zone disk. Now, look at the read write mechanism, how reading and writing operation is done on these magnetic disk or the so called hard disk. So, recording and the retrieval of the data is through a conducting coil. So far I am calling as a head, which is called as a head, read write head. I also shown in the picture of the disk. So, it is a conducting coil. It may be that single read write head per track, all the tracks have this complete disk have the one head only, or it may be the separate heads are there. Say some 1000 tracks are there, for each track you have one head. So, that is fixed position over the track, and in that case head do not have to move. When the request come, one of the, because there are multiple heads are there and corresponding to each track you have a separate head. So, if the request belongs to, let us say, track number 50, so the track number 50 head will be active, and the head, your head actually this is stationary, head is stationary, and that then the disk has to rotate such that the desired sector can come under the this head position, and then that sector can be read. But the multiple head, the disk circuitry becomes the complex, means the composition of disk itself will be a complex, and usually the single heads are used, which the movable head is there, and then head, as per the, once the request comes, then head will move to the desired track for locating that information. So, as I said, the during the read write, the head is stationary for the multiple heads, and the plater rotates. If the single head is there, the head also has to, first head has to move, go to the desired track, and then the disk has to rotate. So, simple write process is that when some data has to be write, the information is coming in electrical form, head is connected to the system bus through the interface, which is called as a disk controller. So, the current flowing through the coil is your head, producing the magnetic field, and then the electrical pulses sent to the head, and these electrical pulses create a magnetic pattern on the magnetized material, and that pattern is recorded as an information. So, that is a writing process. Then in read, for reading, the magnetic field, reading means head is exactly there on the desired information. So, the magnetic pattern is already recorded, that pattern has to be read. So, when the head, the magnetic field moving relative to the coil, your disk is rotating, so magnetic field moves, then it generates the current, and that current will pass in the coil, and it converted into the electrical signals, and then further it is converted into the 10 electrical signal, means it is converted into the 1010 format. So, magnetic to electrical conversion is there through the current passing, and then that information can be read. This coil is the same for read and write. In the floppy disk, usually this head is a single one, same head is used for the reading as well as for the writing. For in contemporary way, the reading is done with the separate read head is there. So, there is a read head is there and write head is there. So, it is partially shielded, the magnetoresistive sensor, and the electrical resistance depends on the direction of the magnetic field, in the which way the magnetic field is moving, accordingly the electrical resistance will be produced, and the resistance changes are detected as a voltage signals, and this kind of read head gives the higher storage density and the reading speed. Now, look at some characteristics, the disk characteristics, means how the head is there, whether disk is detachable or not, like that. So, head can be, it is a fixed or it is a movable head. Usually it is a movable head. In case of the fixed, means I need the head for each track, because information can be belong to the each track. So, each track one separate head is required. So, that makes the cost increase, and the circuitry also becomes complex control system of the disk, and so movable head is a very common. So, in case of the movable head, one read write head per side mounted on the movable arm. You can have the disk with which is on which you can record the information on the both the sides. So, double side or single side. disk can be removable or the fixed disk. Removable disk example is your floppy disk is a removable disk, that nowadays it is not there. So, floppy disk, but the removable you can insert and then you can once your work is over, then you can remove it. And hard disk is something the fixed disk you have detached and then you are not removing frequently. The recording surface can be single sided recording or double sided recording. Floppy disk also used to come in the both way, single side recording, double side recording. So, both sides you have recording, so both side head will be required and your capacity is almost double compared to the single side. Now, head mechanism, it can be contact to the recording surface as I explained earlier. They can be a fixed gap or it can be a flying. So, flying is a floating at some height, head is floating at some height. So, that is initially or first time it is used in a Winchester disk which was developed by the IBM. So, these disks come with the first time as in a flying head or head is floating over the surface, and there is advantage of floating the height in this head. As far as the plate, or you can have the multiple, either single plate is there, single plate, or for larger capacity you can have the multiple plates. Number of plates are, so if you increase the capacity, let us say from initially hard disk comes in some megabytes of memory, then comes in gigabytes and now it is coming in terabytes. So, number of plates increase or the recorded density is also increasing day by day. So, that is why we are able to get in a compact size, we are getting the terabytes of information which we can store in that. So, this is a picture which shows the multiple plated system where multiple plates are there. So, in this picture you can see total 5 plates are there and then the recording surface, both surface are recordable surface, means information can be stored in the both sides, and this is the moving arm on which the head is there. So, for each plate we have the separate head, each surface I can say, each surface have the separate head. Here one head is there, one head is over. Now, within the surface the head has to move accordingly as per the desired track. Now, the set of tracks, say for example, okay, this I am taking one thing, set of tracks in the same relative distance on this recording surface or the plater is formed a cylinder. So, this is one cylinder. Similarly, this another cylinder will be. So, these tracks which I am connecting from the different platers have the same relative distance, they are on the same relative distance on the plate. So, that form a one cylinder. So, now you have a cylinder and the sectors. So, in the multiple plater the tracks will be called as a cylinder. The corresponding tracks joins and makes a cylinder. Now, come to the capacity or storage capability. So, usually the storage capacity of the disk, because as I said that these external storage is used for huge volume of the data, for storing the huge volume of the data. So, that is why the size comes in GBs, gigabytes. So, 1 gigabyte is measured as a 10 raised to the power 9 byte, and the capacity of the disk is measured by some factors, that is recording density, the number of bits per inch, how many bits are, more number of bits can be stored per inch, and that depends upon the sensitivity of the header, the head which is. So, if the technology improves, header sensitivity increase, it can sense even the distance of nanometer of the distance, means the more dense, more bits you can pack on the same area, and that increase the capacity of storage capacity of that disk and reduce the cost as well. The material which is required, that will be less. So, number of bits that can be squeezed in a 1 inch, that is 1 inch segment or track, that is called as recording density. Then the track density, how many tracks you can fit on a given area. So, tracks on number of inch, and then the areal density, it is measured in bits per inch square. So, product of recording density and the track density, which is called as the areal density. So, these are the three parameters on which the disk capacity is measured or determined. Modern disk or the today's time disk are they partition track into the disjoint subset, which is called as a recording zones, as we have seen in the previous slide, some slides some time back. I showed that multiple zone disk and the single zone disk. So, this is the multiple zone disk. So, further the recording density can be improved by using the multiple zone disk. Now, how to compute the disk capacity? So, for that the formula for the capacity is the number of bytes per sector multiply with the average number of sectors per track multiply with the number of tracks per surface, this multiply with the number of surface per plater, and then finally multiply with the platers per disk. One disk can have the multiple plates. So, if you multiply all these things, then you will get the total capacity of the disk. Say, so for example, I have 512 bytes per sector, 300 sectors per track. Sectors per track in a single zone density, in a single zone it is a fine, but for multiple zone we have to take the average, because in multiple zone disk the number of sectors are different on each track. So, that is why usually the average term is used. Then the 20,000 tracks per surface are there, let us say, and there are 2 surface per plater, means both side recording surface are there, and total 5 plates on the disk. So, in that case you multiply all these terms and you will get the total capacity of this disk. So, if you multiply in this particular case, you will get the number that is 30.72 GB or gigabyte. Now, how to calculate the disk access time? When something you are accessing from the disk, a disk access time we know that it is access time is more compared to the accessing a location in the main memory or data in the main memory or your SRAM DRAM kind of semiconductor memory compared, and that semiconductor memory access time is more compared to the cache memory. So, access time is something very critical parameter for the performance of any kind of memory, the amount of time required to access some data. So, here it is large because of the 3 parameters are there. One is a seek time. Seek time is the time required to position the head on the desired track. So, when the request comes, your head is moving on the surface, recorded surface, to reach to the desired track. So, that is called as a seek time. Usually it is in a milliseconds. It's a, because it's a mechanical system, so the time will be large compared to the other time factors. Next time factor is a rotational delay. Once the head is on the desired track, then the disk has to rotate. So, that is rotational delay. So, now disk has to rotate such that the desired sector comes under the head. So, now for that disk has to rotate, for each request the rotation is different, amount of rotation is different, maybe full rotation 1 circle, half circle, 1/4. So, usually we will take the average rotation. So, average rotation, let us say half circle disk has to cover. So, that is why and that comes under the rotational delay. Then finally, the transfer time, the amount of time to transfer the data. Once everything is fine, head is pointing to the desired sector, desired track, then the disk, because disk is rotating and the one bit information has to be read and pass via the head to the destination location via the system bus. So, the total average access time is sum of all these 3 factors: seek time, rotational latency and the transfer time. So, seek time is usually it is given, depends upon the disk technology which is used, usually as I said is in millisecond, and rotational latency, average rotational latency is 1/2R, and R is here the rotation speed and that is in revolution per second. Usually the speed is given in RPM, revolution per minute. We have to convert into, vendors give in RPM, we have to for the calculation we have to convert it to the second, RPS, and for one full rotation time is 1 by R. We are taking average, so that's why we am saying 1 by 2R, and the transfer time is calculated by the formula B divided by Rn. B stands for the number of bytes to be transferred, and R is again the rotational latency or rotational speed, sorry, and N is the number of bytes on the track, total number of bytes in the track. So that gives me the transfer time. If I add all these 3 times, this will give the average access time for that. So let us take one example. Average seek time 4 millisecond, rotational speed is 15,000 RPM, stands for the revolution per minute, and there are 500 bytes per sector is there, number of sectors per track are 500, and I want to read a file which consists of 2000 sectors. Let us say one file is there which is stored, and this file occupies some 2000 sectors. We need to calculate the time to read the entire file. Now the time will depend upon how this file is stored, how the sectors are located in the disk, means this file, whether this file is sequentially stored or these file portions are in a chunk of 512 byte on a different sectors or different tracks. So if they sequentially store, so first case will take whether it is a say for example it is a sequentially stored, all are in consecutive tracks. So the time will be the total average access, total time will be what? Seek time. So seek time is 4 millisecond plus the rotational latency. So I am calculating right now to read one track, one complete track. So seek time will be there to locate the desired track. So that's a 4 millisecond already given, and then the 2 millisecond for the average rotational latency or rotational delay. So 4 milli, and disk is rotating at the 15,000 RPM. So 1 by R you can calculate, that will give me the 4 millisecond. Do not forget to convert this M into S RPM, this is revolution, 15,000 revolution per minute, and one revolution time you have to calculate in the seconds. So that will be the, so that will give me the 4 millisecond for 1 by R. One revolution time will be 4 millisecond will come. So average I am taking, so that's a 1 by 2R, so it becomes 2 millisecond. Okay, so the 2 millisecond is your rotational latency. Then what is a 4 millisecond? To read the one track, one complete track here I am going to read from the formula B by Rn. B is number of bytes, so number of bytes of the complete track I am to read. So the track contains 500 sectors and 512 bytes per sectors. So this the B value, R value, any 1 by R value any I row, I know that. So 1 by R is 4, n total number of bytes. So the total number of bytes is on the track is again 500 into 512. So this cancels and gives me 4 millisecond. So this is the 4 millisecond time to read one complete track. So total time is 10 millisecond. So the 10 millisecond time is required to read the 500 sectors on one track. Now how many tracks are there here? Total 2000 sectors, 2000 divided by 500, so it will give me 4 tracks. One track time is 10 millisecond. Now if the information is stored in the consecutive tracks, then if the information is stored in the consecutive tracks, then seek time will not come in a picture. Why? Because moving from one track to another track in adjacent track is time will be negligible time. Track number 5 to let us say track number 6, it is a negligible time. So that is why that is not considered for the reading the next track. So that is the advantage we are getting when the file is stored in a sequential. The seek time will not come in a picture. So remaining 3 tracks are there, not 4 tracks here. So remaining 3 tracks are there. So the remaining 3 tracks only the transfer time and the rotational latency will be there, average rotational latency. So 6 into 3, that is 18 millisecond, that is the remaining 3, and the total time will be 18 plus 10, 10 millisecond required for the first track, and the remaining 3 tracks only 18. So 18 plus 10, that is a 28 millisecond time will be required to read this 2000 sector information stored. Now if this file is stored randomly, all sectors are at different tracks and different sectors, no consecutive sectors are there. So in that case, what will be the total time required to read the file now? So now you have to calculate how much time, what is the access time for accessing a one sector, and then so that includes your seek time, rotational latency, plus the time required to read one sector. So seek time will be same for one sector 4, rotational latency again will be same for 2 millisecond as per the last exercise or first part of this. To read one sector, transfer time will be, calculation will be B by Rn. So it will give you, if you calculate this thing, it will give you 008 millisecond. So the total will be 6.008 millisecond. That is for reading one sector. Now all sector, any sector, because randomly stored, so these all 3 components will come in a picture now for reading all sectors. So you have to simply multiply with the number of sectors. So 2000. If you multiply with the 2000, then you will get some time in some seconds, some 30 odd seconds that you can calculate. So you can see here there is a huge difference between the access time. There we got only 28 millisecond time to read this file. Now this definitely it is going to be a larger value compared to the previous thing. So the access time largely depends upon how the information is stored on the disk, and that how it is storing, that is a part of the operating system that has to optimize such a way that access time can be reduced for any stored information on that. Now another exercise for you, that is, what is the average time to read or write 512 byte sector for a disk rotating at a 15,000 rpm. The average seek time is 4 millisecond given, and the transfer rate is given 100 megabytes per second. So rotational latency you can calculate because the rpm is given, disk velocity is given, and the seek time is given. Only thing you have to calculate only the transfer time. So 100 megabyte transferred in a 1 second. So now you have to find out how much time is required to transfer the 512 bytes. So that time calculate and add to the seek time and rotational latency, it will give you the answer. So seek time is 4 millisecond, rotational latency will be 2 millisecond, and 0.005 will be the to transfer one sector, 512 bytes. So the total you will add it is 6.008 millisecond. So let us summarize what I discussed in the today's this class. I talked about the secondary storage in the computers, what is the why it is required, and in that we discuss in detail the magnetic disk, the disk characteristics, how the data is organized on the disk, what are the read write mechanism, how read and write happens, and the access time calculation. So thank you very much, have a nice day.